Hello, everyone, and thanks for joining today's Docker webinar from Swarm to Kubernetes and back again. We'll be starting in about another minute. Just going to give folks a little bit of time to join, and we will start the presentation in about 1 minute. Thank you. Hello again, and welcome to the Docker webinar. Again, we'll be starting in just 1 moment. I'm going to let some more folks join in, and we'll be starting momentarily. Thank you. Okay, hello everyone. Welcome to today's webinar from Swarm to Kubernetes and back again. Before we get started, I want to explain how you can participate. For this webinar, please make sure you have joined via computer browser and audio or through internet audio if using the GoToWebinar mobile app. Make sure your speaker volume is turned up for this. If you have any questions during the presentation, please enter them into the question panel and we will answer them during the Q&A session as well as during the presentation. We will also have a Q&A session at the end of the presentation. Please know this session is being recorded and you will receive a copy of the recording via email in a few days. I would now like to introduce our speakers for today, Don Bauer, DevOps Manager, and Mike Noe, Lead DevOps Engineer at Citizens Bank. I will now turn things over to you.
All right, well, thank you. My name is Don Bauer. I am the DevOps Manager at Citizens Bank. And I, in addition to being a Docker customer, I'm also a Docker captain and a community leader. I've been using containers now for about 5 years and just over 3 years in production. I've been both on the developer side and the infrastructure and operations side. And I think I have plenty to bring to this space. And with me, I've got Mike Noe. I'll let him introduce himself.
Yeah, I'm Mike Noe. I'm the lead DevOps engineer at Citizens Bank. I've been in IT, working in operations for about 15, 16 years now. I'm a veteran. I've worked in everything from military intelligence to healthcare to finance and more. And today we're here to talk about why we moved from Docker Swarm to Kubernetes and then back again.
Yes, indeed. So with the history lesson.
So way back in 2016, we began what we'll call the Innovation Initiative. And this was the kickstart that we wanted to put our DevOps practices that we were craving into place. And it all started with containers and Docker. With the Innovation Initiative, we wanted to find a way to use this technology to increase flow through the system, provide constant and accurate feedback to our engineers and the business, and increase our rate of experimentation and learning. Over the next half hour or so, we'll take you on our DevOps journey. We'll talk about how standardizing our images and processes for deploying these services, we were able to increase our deployments from a few times a quarter to hundreds of times a day across our enterprise. We were able to standardize integration testing, reporting, monitoring, and more through Docker Enterprise and a few container smart tools like Instana and the Elk Stack. So real quick, I'll tell you about how this came about. So back in Barcelona, 2018, December 2018, we presented at Barcelona for DockerCon Europe. And there we talked about how we were migrating some of our essential data platform services from Swarm to Kubernetes. During that conference, we learned that Docker was basically fixing all of the reasons that we were moving to Kubernetes. So now we did our presentation on how to move all those services back from Kubernetes to Docker Swarm based on the new services and tools available to us. And that's what we're going to talk about today.
Indeed. So, like Mike said, it started with our innovation initiative. We had a need to change everything about how we built and delivered software within our organization. And as a result, our innovation team was founded by our CIO to solve this need. This was the start of our DevOps journey. So in that, we created 4 pillars that defined our DevOps culture. And those pillars were visibility, simplification, standardization, and experimentation. And to this day, they remain active pillars of everything that we do within the IT organization. Just like Bill and the Phoenix project, we've tried to take the 3 ways and apply them to all of our policies and processes. So the 4 pillars I mentioned, we use these pillars to guide us through our architectural and engineering decisions. So with simplification, we want to make all the processes as simple as we possibly can. And the way we do that is with the next pillar, standardization. And with standardization, everything gets done the same way, and it makes it really easy for us to enforce, monitor, audit, and everything else that way with all of our pipelines. Central to everything is visibility. So every piece of this needs to be visible, not only to our teams that are working on the problems, but to the rest of the enterprise as well. And once you've got all of that in place, you have the ability to experiment. And experimentation is incredibly important. As we've said in numerous presentations, numerous webinars, one of our main goals and credos that we live by is fail fast, fail fearlessly. Nobody should be afraid of failure. It's how we as human beings learn best. And we want to enable that experimentation so people can fail fast and they can fail in a safe environment. We'll cover a little bit more of that here in just a bit.
Effective configuration management is essential to any organization hoping to achieve the kinds of milestones from the likes of Netflix, or Lonely Planet, Google, etc. With containers, we can review the platform just like we would code. Containers help us achieve single-piece flow of our products from development to production. We have system engineers writing code alongside the software engineers, writing their own branches and merging code like everyone else. Containers with Docker Enterprise means increased visibility. Last but not least, we love containers for their ability to increase our rate of experimentation. Because of the way we built our pipelines, any developer can create a personal environment with all of the latest enterprise services with a few button pushes. This allows our engineers to try things out in a production-like way without risking the business.
So at the beginning of our journey, our DevOps and containerization team was an army of one person. And after evaluating several solutions, it was decided that Swarm was the best fit for our needs. We needed something simple to manage, something that enabled our developers to deploy services to their local machine in the same fashion as they would to any other containerized environment, and something that offered complete isolation between environments without needing more than one cluster. So to give you kind of an idea of our timeline with the things that we've talked about so far, we'll start way back November 2016. That's when our innovation team was founded, and we were running 0 containers at that point in time. Jump forward just a little bit to February of 2017. We stood up our first Docker Enterprise cluster, and we started what at that time we called Project Cortez. And at the end of that month, we were running roughly 120 containers. As we move forward into May of 2017, We figured out our CI/CD processes, and we launched an internal product that we call Delivery. We more than doubled our container count at that time, up to about 300. And jumping way forward to February, we launched our very first application that really benchmarked all of these processes. And this application went from ideation into production in less than a week, which really showed us that we were on the right path, we were doing the right things the right ways. And it was Swarm that really enabled us to accelerate that process. And then moving a little bit more forward to April, we added our production cluster. And if I'm being completely honest, this was mostly to make security happy, but it's also a best practice. And I would recommend that anybody else running any containerized services in production do have a separate cluster for their production environment. But we did launch our first true prod cluster in April of last year.
And in August of 2018, we added an operations cluster to run all of our production supporting applications like the outlook stack, delivery, DTR, etc. In November 2018, we migrated our core data services to Kubernetes in an effort to enable true stateful service scaling. This is what we talked about earlier. When we migrated some of our core services from Swarm to Kubernetes, specifically because of some of the tools, and we'll talk about why we did so a little later. But at this point, we were running nearly 2,000 containers across all of our clusters. In January 2019, right after we got back from the conference in Barcelona, we migrated our core data services back to Swarm, since we can now solve the same problems with the things our team already knew how to use. The one major thing that happened in January 2019 is we finally convinced our CIO to issue a statement to all development teams mandating that all new work must utilize containers. And for us, this was a huge win because this allowed us to make containers make our strategy container first as we move forward. So in February 2019, we onboarded an additional legacy development team to our new platform, the new Docker platform, using containers. And by April, we had our first customer-facing application that was developed outside of the innovation team was deployed to production. And it was a huge win. We went from a whiteboard to production in about 7 weeks.
Yes, we did. So the next question is, how did we get here? You've seen the timeline, so let's talk a little bit more about the decisions we made and why we made them. So first off, we'll start with Kubernetes. And since we've already covered why we chose Swarm in the early days, let's start with why we decided to move our core data services to Kubernetes late last year. And at this point, I would normally ask how many people in the audience are using Kubernetes. I can't quite do that here, but if you are using Kubernetes, my question to you was going to be why. And I've asked this question at many Docker meetup and many other conferences and stuff where we've given similar talks. And with that, I'll let you ruminate on this slide just for a moment. The answer I get most frequently when I ask people who are using Kubernetes, and more specifically why they're using Kubernetes in production or as part of their build pipeline, the answer is because my boss told me to. And when I talk to them, I want to know, is that good enough? I mean, are you happy with it? And we can get into more of that later in the questions. But the reason we chose to move some of those services to Kubernetes was not just because my boss told me to.
It's actually pretty easy to see why we consider Kubernetes. Firstly, Helm. If you've ever used Helm before, you know Helm is a great tool whether you're building Helm packages or just deploying other services with Helm. The operator patterns for us were an impressive bit of code that proved that once again, anything that humans can do, computers can do better. And we believe that computers should be doing most of it. The amount of community support that we've gotten, whether we're running Kubernetes workloads or Docker Swarm workloads, have truly been out of this world. The community folks, the official folks from Docker have really made it fun and interesting to work with Docker Swarm and getting all of this out. And now that they offer Kubernetes as part of the Docker Enterprise platform as of Docker 2.0, we now get that same support from the community and Docker official with Kubernetes as well. In some cases, we have third-party vendors who just either won't or don't have the ability to support anything other than Kubernetes stack. For instance, we use a VMware one of our vendors uses a VMware plugin that is called NSXT, which ties in specifically to Kubernetes, but they do not have one for Swarm yet. That's good.
So our experience in going through this process is really what we're wanting to cover here. So the main points were training, security, complexity, and how much we had to change our cluster footprint to support Kubernetes the same way in how we develop the software. So starting with training, our teams were already well versed in dealing with and managing services that were deployed using Swarm. They knew how to monitor those services, they knew how to interact with them, they knew how to troubleshoot them, they knew how to restart them, roll them back, so on and so forth. But when we moved those same services to Kubernetes, suddenly no one understood how to debug, diagnose, or otherwise work with those services at the orchestrator level. We could hop in and out of the containers as much as we needed to, but if you move it one level up to the pods that were running those services, suddenly there was a huge gap in knowledge that we didn't realize ahead of time that we had to address.
So in accordance with the first way, we wanted to reduce our work and process as much as possible. Swarm with Docker Enterprise helps us keep our infrastructure, our implementations, and our integrations simpler, which means less work and fewer issues getting to production. Docker Enterprise mitigates some of the complexity of Kubernetes by plugging in the tools that we already love into the APIs that we love to hate. In the end, though, we felt like we were just getting too far from simple to continue down the Kubernetes path.
Environment isolation did require multiple clusters, unlike with Swarm, which we could run multiple environments in the same cluster and guarantee segregation. And adding more clusters means adding more everything. It complicated our CI/CD processes. It complicated everything about how we were going to deploy what and where we were going to deploy it to. And moving from there into security, for a lot of the same reasons, we ran into issues granting users access to a subset of nodes, which we could do very easily with Swarm using affinity rules and their labels and UCP collections. We were unable to find a solution to do that in Kubernetes. And with everything else, when you're talking about service level constraints, we were able to utilize taints within Kubernetes to restrict workloads, but not user restrictions at a node level. And when you have a subset of nodes that are responsible for very specific pieces of your workload or your application, that actually, as it turns out, was very important for us. So without finding a way, we had to either solve the problem ourselves or move those services back, which is one of the many reasons we did move back. The last piece, as you'll see demonstrated here, is the YAML. So this scrolling representation is a Kubernetes YAML provided by one of our vendors for an application that we do use here internally. And the Kubernetes YAML to deploy this application to any Kubernetes cluster is over 200 lines. And before y'all get mad at me, I know that roughly 30 to 40 of those lines are comments, but still. The Swarm YAML that they provided us to deploy the exact same service in the exact same way with the exact same level of customization was under 20 lines. And that's huge because that's less that we have to train people on. It's much easier to understand, much more clear. And we choose simplicity above all else whenever we can, as long as we're still meeting the guidelines that are set forth with the rest of our standards and compliance needs. So if it's not already obvious, let's talk about why we moved back to Swarm. So like I just said, above all else, we want to keep it simple. Despite our best efforts, either solution did come with some amount of overhead and problem solving that we needed on our end. So what it came down to was we had to decide where we wanted to spend our time solutioning.
And our small team meant that we couldn't rebuild everything in Kubernetes. It just simply wasn't an option. We already know Swarm, we already know how to work within its parameters, and so while moving to Kubernetes it can be a good choice and it's fun to experiment with, Swarm helped us keep our team small and single focused.
And one of the biggest problems we ran into in this transition was packaging our applications. And as we discussed and as was announced in Barcelona last year, Docker app really did solve our packaging issue. And we'll cover that here in just a sec in more detail.
Before we get into that, I want to talk a little bit about our philosophy. Philosophy is something that Don and I spend a lot of time talking about, especially when it comes to how we manage flow through the system. We're both really big fans of the Phoenix project by Gene Kim, George Stafford, and Kevin Bear, as well as The Goal by Eliyahu Goldratt. And through these books, we've learned to make our decisions from the philosophies described there. And if you haven't read these already, we strongly, strongly recommend you go do so.
Do it.
These two books changed our lives and it helped us build the philosophies that allow us to make the decisions that we want to make. Swarm and Kubernetes were built with very different philosophies in mind. Swarm aims to offer high-impact solutions while prioritizing simplicity. Kubernetes aims to offer a solution for every conceivable problem. So within our philosophy, Swarm makes more sense.
So some of the common problems that we discovered when people are considering one orchestrator over another, whether it's Swarm and Kubernetes or Nomad or Marathon, I don't want to leave the other orchestrators out, but no matter which one you're choosing, these are the problems that commonly come up. Things like auto scaling, network segmentation, user access, your role-based access controls, zero downtime deployments, persistent storage, monitoring, alerting, reporting, and I'm sure the list goes on. There's no reason for me to keep going on that front. But these are common things that come up. And if you do enough research and you dig into enough of this, you'll discover pretty quickly that there's all sorts of solutions to every one of these problems that are orchestrator agnostic or really, really close to that.
Stateful services can be difficult. The volumes, the configs, the variables, doing anything with stateful services is just complicated. Kafka, for example, is a messaging queue that runs in clusters. Each node needs to be configured dynamically, and autoscaling is pretty difficult since each of the following nodes must be configured based on the previous one. Both the operator patterns and the autopilot patterns help us get it right the first time, as well as autoscale without downtime. There's also something known as Swarm sidecars as well, and we don't have a lot on that here, but we can definitely answer some of your questions later on with that. Next, we'll talk about exactly what an operator autopilot pattern is. In short, the basic idea behind these patterns is that they should observe, analyze, and act by service. So according to autopilot.io, the autopilot pattern automates in code the repetitive and boring operational task of an application. You guys can read the rest of that. We'll give you a minute. Of course, all of this will be available after the webinar as well. And then operator patterns. It's just a method of packaging, deploying, and managing a Kubernetes application. You can see the only big difference between these two is one is for Swarm, one is for Kubernetes.
So as I said earlier, application packaging was one of our biggest issues that we were trying to solve. And there are products like Helm for Kubernetes that solve this. And now in the straight Docker ecosystem using Swarm, and as it turns out, you can also use Kubernetes with it, Docker app kind of solves some of the packaging problem as well. Our philosophy when it comes to application packaging is if you can't package it, you can't deliver it. And to paraphrase that, if Amazon can't put it in a box, they can't give it to UPS to ship to you. So the biggest piece of this is when it comes to things like upgrades, because deploying a greenfield application is super easy. But when it comes to upgrades, here the example we have is just a generic application that we're upgrading from version 2.0 to 2.1. So in that, we started with what's essentially seven services, and we're adding 3 more. So that's going from 7 to 10 services. But of those initial 7, 5 are also being upgraded to different versions. And in traditional pipelines, if you're using containerized applications, if you're running VMs, if you're running hard iron somewhere, you would have to upgrade and manage each one of those versions and each one of those applications independently. And that didn't work with the kind of velocity we were trying to get with our pipelines. So we turned to other solutions. And as we've stated, we started with Helm. And Helm is fantastic, but it only works with Kubernetes. And we needed something that worked with Swarm and ideally worked with both. And that's what we got with Docker app.
So infrastructure as code has been one of our goals for a long time. We want to be able to build any system by pushing code to repo. That should be your trigger. Using pre-built tools like kops or which is a Kubernetes cluster building tool for AWS, or Docker certified infrastructure templates from Docker corporate for building VMs can make your life much easier. We used the DCI templates to build production clusters in about half an hour from scratch.
And when we started, we were using DCI 1.0, which is a couple of years old now, but coming with the 1903 release, you now have access to Docker Cluster, which is essentially Docker Certified Infrastructure 2.0. And it's one of the things that we're really excited about moving forward with everything that we've been doing so far. So just to summarize some of the stuff that we've talked about, I mean, honestly, one of the biggest issues that we ran into going one way or the other was the human factor. Onboarding new teams with little to no Docker experience, that's going to be hard no matter whether you're going with Kubernetes or Swarm. But what we didn't expect to encounter was moving people that were familiar with Swarm over to Kubernetes and what that challenge was going to be like. The other big piece was how our change management procedures kind of play into these processes and standards. With Swarm, it was really easy to audit and pull everything that we needed to, and we could actually pull all of that in real time from anything that was running if we had to. And I know the same can be done for Kubernetes, but having run on Swarm for 2 years already, it was really difficult for us to address that need to change in a quick manner.
So we covered some of the differences between Kubernetes and Swarm, and we talked a little bit about how Docker Enterprise solves some of the same problems as Kubernetes, and just how we basically used our philosophies to decide how we would move forward. And ultimately, I think that's the biggest thing we want you guys to take away from this is that before you can do any of this, you really have to define your philosophy. You have to know what it is you want out of the system before you start building it.
Absolutely. So with that, before we start with questions, we are going to be shameless. Shameless hiring plug right here. Join us. We do have cookies. You can see what we have available at jobs.citizensbank.com. We are always looking for forward-looking, smart individuals that are excited about technology, excited about containers, and excited about pushing the envelope. And for those of you that are concerned, those cookies are gluten-free. So with that, I know you can laugh at my dad joke, that's fine. With that, I'd like to open the floor for any questions, comments, anything like that that we might not have already addressed during this talk.
Yep, so thank you, Don and Mike. As I said, we are now open for Q&A. If you haven't already, please post your questions into the questions panel so Don and Mike can see those and respond. Guys, do you have any questions currently that you can share with us?
So we've been, watching this through the presentation, and there's we've got at least two that we did want to cover in this portion. So the first question by, I hope I'm saying all these names right when I get to this part, but Grady Bailey asked, can you elaborate on environmental independence in clusters? Interested in why it was easier to accomplish in Swarm instead of Kubernetes. So the biggest piece of that is the networking component. Within a Kubernetes cluster, the networking component is global across the cluster, but within Swarm, with the overlay networks, and especially with the UCP collections, we can restrict those to a subset of nodes or a subset of services or both. We can guarantee that only containers running within that same collection have access to that network. So it's a bit more powerful than namespaces in Kubernetes, at least when we started. And it allowed us to run our testing environment, our staging environment, and our production environment on a single cluster, even though all the services had the same names and whatnot that way. They were essentially namespaced differently with the stacks and with our UCP collection labels. And we were able to restrict environments like production to only running on a small subset of nodes within the cluster. So we can guarantee all production workloads are running on these nodes in the production zone, and everything else can run on the shared resources of what's left.
And for us, that was easier than trying to manage multiple Kubernetes clusters. We didn't want to have to build 40 clusters for the isolation. We wanted to be able to use our single cluster or even a small group of clusters to manage the systems themselves. It was much easier on a small team.
Yeah, absolutely. Which actually, the next question that was asked was, when you say small team, how many members do you mean? And when we started, that team was one. We're still a relatively small team when it comes to platform and infrastructure compared to the rest of the organization. Our team right now is a team of 3, and
we manage all the infrastructure for our department. So it's all of the operations cluster, the production cluster, the test staging cluster, all of the GitLab and CI/CD practices as well. So we needed it to be simple.
Yep, absolutely. So the next question we earmarked throughout the presentation was from Elaine Baxter. If you started with Kubernetes, do you think you would have stayed with it, or would you have still decided to go to Swarm? And that's a tough question to answer. When we did start this initiative, we seriously looked at Kubernetes, and we did seriously look at other technologies, like Meso, Marathon Orchestrator, Nomad. And for us, starting with Kubernetes wasn't an option because we had very limited resources. And again, the team size for who was going to be managing that infrastructure was a team of 1. We only had the ability to stand up one cluster, and we could not find a way within Kubernetes to run multiple environments in that one cluster and guarantee the segregation. So it's a hard question to answer. I think if we could have started with Kubernetes, and that was an option at the very beginning,
it's possible that we would still be on Kubernetes. Yeah, it's hard to say because that project was almost 3 years ago, and things have changed so much since then. But we like where we're at now, and we like the tools we have, and we like what we're able to do with them.
Yeah, absolutely. So hopefully that answers the question well enough, because it was a tough one to think about for sure. Let's see, what else do we have?
Some of these are a bit more in detail than what we went over today, so I'm gonna skip around a little bit. But Paul Skako, are you still using Kubernetes in production? We are not. We have no production workloads in Kubernetes anymore.
Yeah, that is accurate. That will not remain the case over the coming months, but as it stands today, right now, we have zero Kubernetes services running in production. Let's see. So there was another one, details about packaging with Docker app. I don't know how in depth you're wanting to get here, but the essentially what Docker app allowed us to do when it came to packaging was, we could use our existing compose files, and we were able to put all those together. And a lot of people have asked, well, why don't you just make a big compose file and use Docker Compose? The biggest addition with that, is the CNAB compatibility, which there's a lot of tooling that's being built and coming up around the community surrounding anything that supports the CNAB spec. But the other big piece was the parameterization. So we're able to parameterize a lot more with a Docker app based package than we were with any sort of compose package. You can do the same with Helm, but Helm does limit you to using Kubernetes, where Docker app supports both Kubernetes and Swarm with a single standard. I don't know if you wanted to add anything to that, Mike.
No, that's pretty much about it.
Let's see what else we got. Let's see. So how do you ensure security for Docker containers? Is it easy to secure containers in Docker? And if so, how can we achieve it? That's a very broad question.
Yeah, that's a bigger. I like the CI/CD tool question from Steve. I'm not going to try to pronounce that. Agazaday, I guess. So we are using GitLab. We also use
we have an internal tool that we've written as well to help specifically with the delivery and pipelining process.
Yeah, in our CI/CD process, we call on other services too. So we run like Docker and Docker to build our images and run integration tests and unit tests and things like that within the system. And so I think that pretty much covers our CI/CD process. We are using DTR as well. We're not using the built-in repo.
Yeah, and going back to the security for Docker containers, I mean that's stage one for us is DTR. It does scan every image that we push. We have a standard where every repo has scanning on push enabled. So, we can get those scan results really quick. We can figure out if there's critical vulnerabilities that we need to identify, and we'll get that well before we're getting ready to push anything into production. And, the way we do our images internally, we have one base image for any of the given things. So like we have Alpine, we've got Ubuntu, we've got CentOS, we've got a whole bunch of Java and Python base images that all extend from the Docker Hub in some way, shape, or form. We just pull them in so we can do that scanning. We can do the remediation of anything that might come back ourselves. And then everything else internally, all of our other services, utilize those base images. So if we need to fix something in the underlying Alpine or Java image, we're able to apply that update in that base image immediately, and then all we have to do is redeploy any of the other services that extend from those base images, and that fix ends up rolling out. So that's one piece of it. I mean, when you get into the runtime security and things like that, that's a much deeper conversation. There's tons of companies, tons of products out there that have solutions for runtime security, including network microsegmentation, binary limiting, things like that. Companies like Aqua or Twistlock, and I know there's probably a dozen others right now. So I would recommend doing some research with those guys to kind of answer the rest of the scope of that question.
All right, let's pick another one here. The monitoring one's pretty easy to answer. That kind of fits in with what we talked about today. We use Instana. It's a service that we pay for externally. It's a vendor we work with that ties into our Docker host and reports on all of them. It helps us do all kinds of stuff. We can see the active like if we run a lot of Java services, so we can actually get like a real-time heap dumps if we need to with Instana. We can set up a myriad of alerts, and we have alerts and monitoring on all kinds of stats, everything from the JVMs to the containers to the Spring Boot framework. Everything about that container we can pretty much monitor and report on, and that's how we do a lot of our right size testing and just main general configuration.
Yep, absolutely. I mean, in addition to that, we do utilize, UCP for uptime metrics, health reporting, things like that. Again, we get all of that through Instana, but we do have some internal tooling that relies directly on that rather than a cloud-based service. I think that pretty much covers the breadth of it. Here's a real easy question. If you can say approximately how many nodes do you use in your production cluster? So we can say that. We've been very public about that. I don't think the count's changed since Barcelona last December. Our production cluster is currently running 40 nodes, 5 of which are manager nodes, and then the rest are workers. So like I said, that was an easy question. Let's see. How much do you have to lean on the enterprise features of Docker? Do you think you could have pulled off most of what you did using the community edition?
I would say that we could probably have done it. There's other visual tools like Portainer to help you like manage your containers and stuff like that in a Swarm scenario, even using Community Edition. I would say that the biggest thing though that we lean on is the enterprise support, so which has been phenomenal from Docker Enterprise. Anytime we need anything, we can usually just hit them up in the Slack channel, and within a few minutes we'll have an answer to whatever our problem is. And even if we can't do that, we've been able to submit tickets to Docker Enterprise to get things resolved much more quickly than I think we have been able to with pretty much any other vendor we've ever used.
Yeah, I think the other big piece here is, so the answer I would say is 80% yes, but it would have involved a lot more time. We would have had to put some development time and resources into giving us the things that we didn't have. When it comes to the scanning that's built into DTR, that's something we would have had to replicate ourselves and build into our process. Same thing with UCP, like Mike mentioned, there's other UIs out there like Portainer that can help you with managing clusters, running Community Edition. But with UCP, we get that API as well that we've leveraged since day one. Same thing with DTR, the DTR API for the registry. We've built into almost every piece of our CI/CD process. And in addition to all of that, with enterprise, we're a bank. Auditability and compliance and things like that are incredibly important to us, as you can imagine. And with enterprise, they've got the FIPS compliance, they've got the audit logs all centralized and exposed and pullable. We're able to ship those to all of our systems without having to really do anything extra. So it's like I said, I think it's about 80% yes. If you go from a functional perspective, I'm sure we could have. It would have taken us longer, and we'd have a lot more internal pieces to maintain ourselves. But when you go beyond just the functionality, again, when it comes to things like compliance and auditability, I'm not sure we could have done that in a fashion that our auditors would have been okay with. So that's where the other 20% is. So that 20%, no, I don't think we could have.
someone's asking about ingress. What do we use for ingress? So we're using Traefik to manage all of our like software load balancing needs and like just general ingress needs. It works really well. It's super simple to use with Docker Swarm. You just have to put the right labels in the right deploy stanza in your Swarm files, and it picks them up automatically. It's easily one of the best tools we have.
Yep, and we do have an F5 in front of all of our Traefik deployments, and then each cluster has two running instances of Traefik, one for internal LAN-based traffic, anything on our internal network, and then a separate one that exposes anything external, anything that's publicly accessible. So we've got the F5 and the different F5s in front of both of those as well.
So this question says, as for the DevOps promise, the resources should be optimized. How come you increased your team from 1 to 3 when moving to containers? So we didn't. We started the team with 1. It's not like we moved to containers with 1 person managing operations. Like we started a whole new team called Innovation, and the ops team for that group was 1 person when we began. As the demand has increased for this platform, we've had to increase our numbers to help keep up with that.
Yeah, and that number moving from 1 to 3, like the Docker Enterprise and the containerization platform and the clusters that we're running, that's only one piece of our responsibility as a team. And we're also maintaining all of our source control systems, all of the pipelining systems, the CI/CD stuff, all of our logging and monitoring. You know, there's a wide breadth of other services and platforms that we're responsible for, in addition to the Docker enterprise environments as a whole. So the increase was just to take on that additional stuff, give us more ability to be involved in architecture meetings, standards meetings, you know, the ability to kind of push what we've built forward. With just 1 person, there's not enough time in the day to attend all those meetings, you know,
and do any work.
Yeah, exactly.
Does your Swarm cluster sit on top of physical host or VMs? We use VMs inside vSphere, and we use the Docker certified infrastructure templates to build those out in vSphere. We're using vSphere 6.0, looking to migrate to vSphere 6.5 very soon.
Yeah. Do you have any cross-region deployment, and how does it work?
We do not.
Well, we kind of do, but we're working on that this year. So one of the big things we're looking for in the cross-region thing, and I know Docker's talked about it in the last two DockerCons, is Armada. You know, their federated application management, and really, as this moves out, that's what we're looking to utilize for cross-region deployments. We do have a I'll call it a warm spare kind of infrastructure set up right now. You know, Docker's helped us with that. With, you know, we can package all these up in containers. We can simultaneously deploy these services in 2 different places, and then our persistent storage allows us to replicate our volumes between those 2 data centers as well. So there's about a RPO RTO combined of one hour between our primary and our secondary site, but and that varies for service. In some services it's as low as 5 minutes, but that's really the extent of our cross-region deployments at the moment.
We don't have anything in the cloud either. It's all on-prem.
Yeah, the next question was about microservices deployed in the cloud, and right now 100% of our infrastructure is on-prem. Let's see.
And the backend's all configured with Ansible and Go.
Let's see. Sorry, we're having trouble catching up with all these questions here because we're not looking at them as we're answering.
This one says, how are you handling service updates currently? So a lot of our services, the tool, I guess, what you call it, setting it's called inside the Swarm YAML is the order that your services deploy, and it's either stop first or start first. In most cases, especially all of our stateless applications, they are start first. So they deploy in like blue-green scenarios. So an entire new set of services will be deployed with the same backend address and the same traffic front end if necessary. And so we deploy a whole new set once the containers are up and healthy. And this is all done pretty much automatically through our flags and everything like that within Docker Swarm. The old version of the services go away. All of our services are configured to roll back to a previously known good config if for some reason the new one fails. So if we deploy new services out there, even to production, if the services never come up, the impact will be zero because the old services are still there until the new ones are confirmed good.
Yeah, and we actually aren't using Docker Service Update. We're using Docker Swarm Deploy in all those cases, and it's smart enough to figure out what it needs to change, what it needs to add, things like that. And again, that's for the older stuff that's not already packaged with Docker app. Let's see. So going back in the question history here, we've got one. You said that there is a way to define separate groups and environments without having to use separate clusters using Swarm. How does Swarm define that line? Are they like virtual environments? So there's a few things at play here. So the enforcement of that isolation we're doing with UCP collections, which is a Docker Enterprise specific feature. But if you remove that, we've got some YAML pre-processing in front of our deployments that will, I add basically a prefix to things like our networks and our volumes. So when we run that through the deployment, the Docker stack deploy, we're guaranteed that if we're deploying to prod, all that's going to be prefixed with prod's 8-digit ID. If we're deploying to tests, it's going to be prefixed with test's 8-digit ID. And we don't get any overlay there. They're using different networks. Without UCP collections, we can't easily restrict what workloads are going to run on which nodes, which is, again, that's one of the enterprise specific features, but just the nature of the way stacks work and our environment prefixing that happens automatically in our pipeline, that's the only piece we would lose, is the ability to guarantee that the production stacks are going to run on this one subset of nodes and everything else can use the shared pool. Without the UCP collections, everything would be using the same shared pool, but those networks still wouldn't have access to one another, just because of the prefixing and the nature of how Docker stacks work.
And I wouldn't say they're like virtual environments. I'd say it's more like namespaces and what's it called? C groups.
Yeah, yeah, something like that.
Yeah, but for networks.
So let's see. All right, if you had to start from scratch and were making a decision about Swarm versus Kubernetes without any prior knowledge of either today, would you still lean hard towards Docker Swarm?
I think we would go with one of the services out there. There's a lot of vendor services now that do like the Google Kubernetes service, or even Docker now has a Kubernetes service, and there's services in the cloud that manage the operations and infrastructure stuff on us a lot better today than they did 5 years ago. So I think today I would look really hard at a lot of the vendor services in the cloud to do a lot of what we're doing today.
Yeah, I think one of the things we emphasized in the presentation is simplicity, and whether you're going with Kubernetes on site or one of those cloud providers, there's still a whole lot of complexity that's involved there, and there's providers that make it simpler than others and things like that. But I think following our philosophy, if we were to shake the Etch-a-Sketch so to speak, and start from scratch today, I still think we would end up on Swarm, especially if we're going to continue to run our stuff on premise. Sorry, I just read the last question that was submitted. But yeah, we would definitely, I think we would still definitely end up with Swarm, just because the philosophy so closely matches what we're trying to do with everything else internally. You know, we don't need an answer for every single possible thing that we could possibly encounter. We need something that's simple and offers high impact solutions for, you know, the most common problems. And that's what we get.
So this last question says, I happen to already be partway through the Phoenix project. Does Sarah's heart ever warm up to the IT people? Sarah's heart is
Spoiler.
as cold as space. As cold as space. It's a great book though. We've learned a lot, being able to take stuff like that and apply it to what we do every single day. If you've not read the Phoenix project and you're doing anything IT related, managing even just a handful of systems, it will change the way you think about how you build and interact with the systems around you.
All right. Well, I think
And
we're
guys,
right up on time. So thank you for attending today. I'll hand it back over to Melanie, and I'll let her close us out.
great. Thank you, Mike. Thank you, Don. Thank to all of you for all the great questions. We do love an interactive audience, so thank you for that. And again, thank you to our speakers, Don Bauer and Mike Noe from Citizens Bank. We appreciate your time today as well. Just a reminder that today's session was indeed recorded. You will receive a follow-up email to view the recording, which you will receive in the next few days. And again, we thank you for taking time out to join us, and we hope to see you at the next Docker webinar. Thank you, everyone. Have a terrific rest of the day.
Thank you.